Okay, in this example, we're calculating induced EMF again here. But this is a different case. So this is induced EMF. So the idea is, imagine that we have a circuit, and we have an inductor connected to it. So inductor is really just like a whole bunch of, a loop of wire, right? And this is the symbol for it as a component of a circuit. And when we have a time or a power supply that changes with time, it has a symbol that looks like that, and this is called an AC power source. So this is AC, changes with time. So that means that, and a lot of times when you have an AC power source, whenever you have an AC power source, you have a time varying current. So a time varying current is going through here, and now that means, like, imagine I had a sine wave or a cosine wave, right? It's going to go. It's going to have a peak and a trough, and it's going to change. And so it's going to be going forwards and backwards. So the current's going to be going forward and backward through this loop. And that means that my magnetic field created by that coil is going to change. And so if I have this coil and it has a changing current going through it, it's going to have a changing B field. And that changing B field in that coil is going to create another current. So this whole loop itself is going to act and try to create a current to stop that change of the B field in it. So there's two currents: the current from our AC source, and then the current created by the coil itself to block that change. And so we can calculate that. I always found that interesting and kind of hard to understand. So let's think about our givens and finds. So given, we have L is equal to 180 millihenry. For this is the L for my coil. And then I have my I final is 10 amps, and I initial is 25 amps. So right there, you should think, I final and I initial, that must mean I have a delta I, right? And then I have a delta T of 0.35 seconds. That's a 5. And I'm going to use the equation delta V is equal to negative L di dt. And I can also write that negative L delta I over delta T. Right? And so my delta I is just I final minus I initial. So this induced EMF, this delta V, is really, right, that's my EMF that's induced. So I'm going to say EMF is equal to a negative, so 0.180 henries times, so my final is 10 amps minus 25 amps over 35.35 seconds. And when I do that multiplication out, I get, now notice this is 10 minus 25, so that's going to give me a negative number. And I have a negative here and a negative here, and that'll give me a positive value. And when I multiply, I get 7.71 volts.